is there is what we call sigma. The sigma bond is bonding that results from the collinear or coaxial interaction of atomic orbitals. So that one said and done. For the purpose of the concept that we have discussed about, we're going to see that benzene is a planar molecule, which means it is atoms, because we talked about the alternating double and single bonds. So if I draw this illustration here, at these specific points we have carbon atoms, and the various orbitals at each individual atom. I can just use that rough sketch to represent that concept that I'm talking about, the pi and sigma bond. So when we talk about a planar molecule, a planar means that all the atoms lie on the same plane. So for a planar molecules, all the atoms lie on the same plane, and from basic geometry we know that a plane is a two-dimensional figure that extends indefinitely or infinitely on four sides. So in that case, that is what refers to the term a planar molecule. So benzene is a planar molecule in that case, of course, and we have said that it's a liquid at room temperature, which is a good solvent, but it is toxic. And in this case, we have given it a term that is we have referred to as carcinogenic. Now, going to the structure of benzene, I'm going to use two representations. Of course, from our various topics that we have discussed in some of our videos about the structure of molecules on how to represent organic molecules, of course, we talked about the concept of compressed formula. This one we can have CH2 or maybe CH3. This is a compressed formula for carbon atom, and this is an alkane. This is a four carbon atom molecule. That's an alkane, single bond. So this is a butane for that case. So this is a compressed formula representation of this kind of an alkane that we have called, of course, butane. So in this case, we have different kinds of, we have an expanded structure, compressed structure. For instance, if I try to draw the compound that I've given the formula for that case, that this is HH, and then we have that one, this one, this one, this one, and this one. So that's an expanded formula for that kind of a molecule that we have called butane. And it falls under the class of alkanes, that's of organic compounds. So in this case, we can as well have the line structure for this kind of a molecule. So the line structure representation, which we can represent as this. And we say that at each junction of this is a carbon atom, and their respective hydrogen atoms which are completing the octet state for that kind of a molecule in order for it to gain stability. So in this case, when we talk about benzene, it's going to fall under a class of organic compounds that we talked about, of course, which has got alternating double bonds. It's a cyclic compound, and we have talked about the concept of it being planar. So if I put two representations for this kind of a molecule, benzene can be drawn using this first structure or the second one here. So at any point when I'm going to represent a benzene molecule, or in our discussions using either of these two structures, it just means the same, but the same thing. So in this case, the first structure, this is known as a Kekule structure. Kekule structure, while the second one is known as the Robinson structure. So whenever you come across